The anesthesia machine receives pressurized gas from the pipeline and cylinders. The machine provides regulation of the pressure and flow of these gases. The hypoxic guard is meant to prevent a hypoxic concentration of nitrous oxide from being delivered. The selected fresh gas flow mixture then passes through a vaporizer, allowing for the addition of a selected concentration of a volatile agent. A safety interlock exists which should only allow one volatile agent to be dispensed into the fresh gas flow at a given time.
The O2 flush valve is operated by pressing a button and allows for the immediate delivery of a large volume of oxygen into the circuit. This is always 100% oxygen that bypasses the vaporizers regardless of their setting. Next, the fresh gas flow and any added volatile anesthetic flow to the common gas outlet, which feeds into the breathing circuit. The basic functions of the breathing circuit are to deliver the gas and volatile agent to the patient without allowing for the rebreathing of exhaled carbon dioxide, and to allow for positive pressure ventilation. Numerous types of breathing circuits exist. The circle system is the most common and is utilized in virtually all anesthesia machines. The circle circuit contains some key components. These are the two one-way valves, the inspiratory valve and the expiratory valve, the reservoir bag, the adjustable pressure limiting or APL valve, the carbon dioxide absorber, and finally the Y piece at the patient end. The one-way valves allow for gas to flow in only one direction within the circle. On inspiration, fresh gas flow from the common gas outlet, as well as any gas in the reservoir bag, flow through one hose into the Y piece and to the patient's lungs. Exhaled gas flows through the other hose into the reservoir bag and through the CO2 absorber. The APL valve setting determines the amount of pressure that builds up in the reservoir bag, circuit, and patient's lungs before excess gas is vented out of the circuit through the APL valve and into the scavenging system. With the APL valve open, the patient can breathe spontaneously. It can be partially closed and the reservoir bag squeezed in order to provide manual positive pressure ventilation. The position of the APL valve determines the maximum pressure within the circuit. The fresh gas flow rate determines how quickly that pressure is reached and how much gas is fresh versus rebreathed. The fresh gas flow rate can be manipulated in order to allow for the rebreathing of all, virtually none, or some fraction of the gas and volatile agent delivered into the circle circuit from the fresh gas outlet. This is described, respectively, as being a closed circuit, open circuit, or partially closed circuit. Rebreathing of gases provides for economic cost savings, as much less gas and volatile agent is necessary. It also allows for decreased patient heat loss and improved humidification. It is important to remember that the changes you make to the concentration of gas or volatile anesthetic will take time to equilibrate as the new concentration flows into the circuit and the gas already in the circuit flows out through the APL valve. Increasing the flow rate of gas will increase the speed at which these changes occur. There are numerous types of ventilators, including bellows, piston, and turbine-driven. When the ventilator is turned on, the APL valve is bypassed and therefore no longer used. Instead, the ventilator itself is set to regulate pressures within the circuit. Pressing the O2 flush button while the ventilator is on may cause barotrauma to the patient, depending on the specific design of anesthesia machine and ventilator in use. Therefore, this is not recommended. All of the various components, from the pipeline to the vaporizers to the circuit, can be characterized by the pressure at which they operate.